Hey everybody, good morning. Hope you're doing well. It's Eric here, MNChaser. Thought I would do another forecast discussion, review of the weather over the next 48 hours for Minnesota. Starting things off, looking at the Storm Prediction Center's overall outlook, broad spread thunderstorm, potential across the United States, with some elevated severe risks in western Arizona and the eastern parts of Virginia, North Carolina. Focusing on Minnesota today, just taking a peek here, tornado, wind, hail, all fall below the thresholds, for an elevated risk, for these areas. So while we are looking at thunderstorms, the potential for these storms to have damaging winds, damaging hail, tornadoes, those types of things are really low. Doesn't mean that, these things couldn't exist, just that the potential for them and the size of them or the longevity of them are going to be very low. So kind of navigating in here to the Twin Cities, NWS, so MPX out of Chanhassen. Just a quick little look at what the week is ahead here. So temperatures getting up into the low mid 80s today. You can see an isolated risk for thunderstorms. During the daylight hours, this is going to be generally to the north and the northeast part of Minnesota, but those storms will continue to progress down to the southern part of Minnesota, continue overnight, and we should see a pretty good chance of storms continuing into Tuesday as well. Wednesday overall, a general trend of drying and warming up, and you can see the rest of the week into the weekend. Temperatures on the climb there, with maybe a potential, keeping an eye on things for the weekend to maybe have another chance of rain again. Just taking a quick look at the radar and overall hazard outlook. If you were up early this morning, you probably noticed widespread fog, northwest Minnesota, southwest Minnesota, around the metro area and to the east. A lot of Minnesota woke up to temperatures in the high 60s with dew points matching. So 100% humidity at the surface means we're going to see condensation, clouds at the surface, which is fog. You can see some of these fog advisories are still in effect in Minnesota. Some of them have expired as the surface is warmed up this morning already. We've seen the sky clearing and that fog dissipate. Overall, there's a kind of a low pressure system and trough that's sitting up here in Canada, above the Lake Superior area, and generally speaking, this has been causing a number of storms here up in Canada, and has created an outflow boundary, essentially a cold air. That gets released as a downdraft from the storm, gets pushed out in front of the storm and kicks up, a few more of these storms. And so what we're seeing is the development of this low pressure system and the outflow boundaries kicking up some of these storms as this is progressing towards the Wisconsin area and southeastern part of Minnesota. We'll dive a little bit more into that, but this is kind of a quick peek at what radar's looking like across the upper Mississippi Valley and Northern Plains area right now. So let's take a dive into the satellite. I like to do kind of a top-down analysis of what's going on right now, just to kind of get a view of across the continent, pretty much across the United States, where the patterns are moving, where the moisture is, and that type of thing. So right now we're looking at middle level water vapor. So all this is really telling us is the absorption of infrared versus looking at satellite, which is more like a visual photograph. This is using infrared and looking at the temperatures there and inferring from the temperatures where the moisture levels are. So we're kind of looking at an absorption layer that represents the middle of the atmosphere. And you can see here yellow representing dry air, blue representing more neutral to moist air, and green representing clouds and very thick moisture. You can see this plume of moist air with this convection that's sitting up here in the northeast part of Minnesota, and that's working its way down. You can, if we maybe zoom out just a little bit and get up to the upper levels, you'll be able to get a good view of some of the jet stream attributes here, right? You can see there's definitely a flow here of wind in the upper layers. You can definitely see a push up here northeast, right, as this moves up that way. You can see another push down right here, as well as definitely some cyclonic rotation that's associated here. So number of features we can keep going on this, but just to give you a very high level view of the pattern, we can be looking at water vapor where we might not necessarily have clouds in a particular area. Water vapor can help us to determine some of the flow that's there. The other thing we can do is just take a quick peek at Minnesota overall. Here we can see that convection up in the northeast. We can see that a lot of this, just as it's getting into the very northwestern part of Minnesota, is all kind of pushing down southeast. And that's spreading out as it goes. You get a little bit of a view here of what that outlook boundary or the outflow boundary looks like. You can kind of see that circular pattern that's right there. You get a view of that as that it spreads out, essentially kicks up more of those storms as it goes and acts as its own little kind of front out in front of the storms that are being created there. The other thing we can do is take a look at Minnesota and look at some of the lower levels here. So we can see this dry air, this pocket of dry air that's sat in between the storms from the weekend and what we saw kind of yesterday and yesterday afternoon and overnight. This kind of lower level pocket is going to get disrupted by this moisture and convection that's created here. So as that air rises, it will condense as it cools, creates moisture, and we start to see that on these infrared visuals, and we can see that coming down across Minnesota. So again, very high level, view of the satellite. We can take a look at the Weather Prediction Center, their view of the fronts overall. So we drew a couple of those at the very upper level, just on where we thought the jet stream might be moving. This is a view now looking at the surface, right? So what's happening above and what's happening at the surface are all very related, but they're not necessarily identical or in the same place geographically. So what we have right now is an overall kind of high pressure that's sitting here. This morning waking up or last night, the surface pressure was around 1020 millibar, and then waking up that had dropped, even into 1019, 1018. So we're seeing this dropping of barometric pressure at the surface. Already now a lot of the areas of Minnesota, down south is starting to see the 1018s. So we're definitely seeing a pressure drop, and that's related to this low pressure that's developing in the surface up here in northern Minnesota. This will continue to track. This whole system will continue to track south, and it'll bring with it this cold front, right? And this cold front will be important because this cold front will come through and it will act as our lifting mechanism. That will act like a wedge, kind of pushing some of the surface air up and initiating some of that rising motion into an environment that is, conditionally pretty unstable or kind of sporadically unstable and buoyant. So we'll talk a little bit more about this, but just pointing that out that as we look at WPC's projection, you can see as this develops towards the afternoon, you can see that outflow boundary that they mapped here, right? That's going to continue to progress down. And then as we continue on into like 7 p.m., there you can see that cold front starting to come down and into tomorrow morning. And by tomorrow afternoon, that cold front should be mostly passed through Minnesota. But as you can see, it's going to take almost 2 days for that cold front to move through. And that's why we're going to see sort of this slow progression, not like those storms where a cold front comes through from the west and kind of blasts through us. And we see all of that happen within a couple hours. This is going to be a little bit of a slower moving system moving south. And it's going to create this kind of wider spread, scattered to isolated, storms that just kind of linger on for a day or two. Here's an overall look. This is a little bit outdated now as 9Z. This is as of 4 a.m. Minnesota, Central Time. But here were some of these numbers, and we can see where this fog was developing. Here you can see we've got 59 over 59, 64 over 64, 63, right? So this whole band, this whole area here, all seeing 100% relative humidity at the surface. Obviously, they're going to wake up to fog, and that's what we did see. But as of 4 a.m., we could start to see some of that fog developing here. Another thing to point out here is, as of 4 a.m., here's where this 1020 line is, right up here in Canada, right? And then that low pressure, that's developing up there. For the most part, the whole kind of, northern plains, central plains, and upper Mississippi Valley has been a pretty stable from a pressure system. We've been sitting around that 1020 to 1018, range for the last, 48 hours or so. But that's going to all change as this system comes down, and a much more significant low pressure will move across, and again brings fronts and different air masses with it, which will act as our lifting mechanism. Taking a quick peek here at the surface pressures as well, so you can see this is a little bit more updated now within the last hour. And what we can see here is we're already starting to see some of this low pressure get developed and pushed down. This will continue to play out. If we just kind of do a little bit of modeling here, you can see this continue to play out, and even there already, 6 hours out, we're starting to see this the pressure around the surface drop. So just kind of a quick peek at what we're seeing at the surface. We can keep working our way. We can keep working our way up into the atmosphere a little bit here, so we can take a peek. At the surface, we'll look really quickly here at temperatures. So again, we're seeing 70s now across most of central and most of Minnesota. It looks like we're seeing about 70 degree surface temperatures that are here. Dew points definitely still in those middle high 60s. So it feels kind of muggy if you were out this morning. It's going to feel a little bit thick in the air. It's just not quite hot yet, but we're going to get there as the sun pretty much has an unobstructed view of the surface to heat it today. Let's move up just a little bit in the atmosphere. Let's jump up to the 700 level. As you can see, we've got this development of this low pressure as the isobars here are showing us. Here's the thickness of the 700 level. So this is the potential thickness, not necessarily the isobars themselves, but we can see the shape of that trough starting to form as it gets developed there. So let's keep going here and keep moving up into 500 level. As you can see, there's some depth to this formation. We're seeing very similar shape between the 700 and the 500, which just kind of goes to show the strengthening mechanism of this, and again the depth of that feature and maybe how prominent and impactful it's going to be into the environment that's there. So keep going up here, and I want to take just a quick peek at the 300 level. Normally would want to zoom out just a little bit broader here on this, but you can see some upper level divergence that's going on, and that upper level divergence will translate in proximity to a lower level convergence. So divergence, as you know, would be like the getting to the end of a traffic jam, if you will, and having the ability for air to spread out, right, or go faster. That allows it to diverge and spread out. And when that happens, what we would see normally then is at the surface, we're going to see a convergence. And that convergence is more of the air coming together. And that air coming together is what, when you have this divergence, if you think of it this way, when these winds have the ability to spread out, it creates a void, right? So where this pink and the green is here, there's a void that's there. And due to laws of conservation of mass and other physics laws, the atmosphere is a contained space. And when you have this divergence that exists aloft, something has to replace that void. And so what's going to happen is in this area, we're going to get air. Now, I know this is kind of a 2D view of this, but we're going to get air that is going to come together here, right? And it's going to converge and it's going to rise. So imagine this rising air that's coming up there, right? And again, it's not exactly directly over this area, but just to show you, it's sort of an opposite effect that happens at the surface. So while we're looking very high right now on the chart, my blue arrows represent the surface, and that convergence and the air coming together and that rising motion that's there is what's going to create the general tendency for air to rise. And when air rises, warmer air at the surface will eventually cool. That will create clouds. That will create precipitation, and that's what's going to create our rainfall today. So divergence aloft and that convergence down at the surface will create a rising motion. All of that is an important feature and component to an atmosphere that will be creating rain and storms. So yeah, I think that's kind of the view overall. I wanted to do just a quick look at the sounding from 7 a.m. this morning. So again, you can see the surface here in Chanhassen, 66 over 65. It's right there. I think already starting to dissipate some of that fog, right, that was there. We're already starting to see a little bit of a warming. But this temperature inversion that you see here is very common, that exists overnight. The surface has the ability to cool down much faster than the air aloft does. And so while last night the temperature might have looked something like this, as we went to bed, right? This straight line that was there, this line will cool off, and that's why we see that cooling, and it creates that temperature inversion here overnight. Out of the gate, just looking at things, this morning, relatively low CAPE, which is not surprising at all at the surface and at the mixed layer due to this temperature inversion that's here. A thing that's going to be a limiting factor for us today and very important is, at least out of the gate right now, very low, and kind of moderate bulk numbers here for bulk shear. So one of the things with storms is while we might have plenty of CAPE and we might have plenty of moisture and all the ingredients that we need, this would be like trying to bake a cake without maybe yeast. And maybe that's not the perfect analogy, but as an analogy, you can bake a cake, but it will be more like a pancake versus it being like an actual cake, right? So one of those ingredients is missing. It's not that it's not still a cake. It's just not the light, fluffy cake that you wanted. Shear plays an important role in storms in organizing and sustaining and kind of upscaling these individual isolated storms. And if without that shear, what you get is a more broad upscale. And so you'll get these pockets of little isolated storms that are scattered across an area where it seems like, there's an isolated storm here and an isolated storm here and there, but they never really grow up to become a supercell. And that's typically where we would see very large hail, very damaging winds, tornado threat occur, is when we have these shear numbers here closer to double what they are right now, and double or potentially even triple. And so we just don't have those. And what the shear is really measuring is the difference of wind direction and speed with height. And so if you were to dig in and learn a little bit about wind barbs, you've got a direction here, you've got direction here, you've got direction here, and a little bit of a flip now as we get up right into the atmosphere. But for the most part, we've got a little bit of a directional shear, but when you look at this, all of this wind through here is identical. There really is no low level shear at all, which is why we're seeing low numbers here, and and through this whole area as well. So that's going to be a limiting factor for us today. And as we get into the day, this will be the reason why we see some of the actual storms the way that they are, the storm mode the way that they are. And again, we can see just overall, numbers. I guess looking at some of these index numbers here on, significant tornado parameter and supercell parameters. These numbers are all 0 right now, as expected. But as we get towards later in the day, these numbers aren't going to dramatically increase for anybody who reads off of these indicators. They just aren't. They just aren't. There aren't enough conditions that are being set up between. And again, bulk shear is going to be one of the largest that limits us for the day. Probably enough to look at in here. There's a dozen other things that my eyes are going to. Lapse rates, being generally low and fairly close to, stable here. So these are pretty normal conditions for the morning of today. But this probably nails it. Best chance is obviously rain. We're not expecting snow or sleet or anything like that, but we're really not expecting much in the form of supercells, significant hail, or tornadoes. Then this is pretty much bottoming out here at 0 overall. So enough on the sounding. Want to dive in here now and take a look at some of the model data. So this is kind of looking now at what we are forecasting for the rest of today. We are looking at the GEFS, which is the ensemble with members including GFS. And so this is our global forecast system in North America, view at, let's take a look here at 300 level. So what we are looking at, and actually, what might be a great view here is, let's look at Northern Hemisphere overall. We should be able to get a good view here of the jet stream and the motions that it does. So that, the jet stream isn't just this one wave of wind. It circulates the entire globe. And you can see a pretty well defined outline of where these winds go. And, I guess here some of these winds go down, some of these winds go up, but you could see just a rough pattern here. And in fact, this probably doesn't do it justice. If we really look at this out, it looks like this spins down a little bit broader and through over there, right? So we've got this kind of overall view of what the jet stream is doing. These are the large scale Rossby waves patterns. These don't move as we, if I were to scrub across here, you'd see these don't move all that much, right? They aren't, it takes them days. Look like we are already into August at this point before those things move. So they're very slow moving, and they tend to reinforce the weather around us. So you can see these large, cyclonic, these circulations that are here, and the jet stream that meanders in between those areas. But I just want to point that out because as we dive into the U.S. part, now we can see the jet stream a little bit here as it will move across the United States. So again, here's some of these broader cyclonic circulations that are here, and the jet stream, these streamline green lines that are here. So as we can see this go through, and this is going to skip by in 6-hour increments, right? So we're going to get through Minnesota here in Monday in a couple frames. But as we see this, right, for the most part, the flow of this isn't changing, right? We've got this flow pattern that looks like this. What we're going to see is if we skip a couple frames ahead here, we'll start to see the formation of a jet streak. And this jet streak is a really fast, area right here. So 71 knots versus over here 29 knots, right? This is very slow moving jet stream air. This is much faster, and even 72 is not necessarily even on the high end for jet stream, right? But just this is a significantly more condensed area of faster winds that flow through the jet stream. And so what that's going to do is it's going to continue to push down here, and this is into about 7 p.m. now, Tuesday afternoon. But that feature, that jet streak feature, what it's going to do is it's going to help as this comes through this way. It's going to intensify this trough that gets developed. So if you were to come backwards here just a little bit, you would see we don't have too well defined of that feature just yet. But as that comes through, it's going to really dig that trough in. And look here by Wednesday afternoon, we've got this like trough that has now developed over Wisconsin Great Lakes area. And this is what really the development of this is going to drive our weather for the next 48 hours or so. So we'll take a look at that a little bit more in detail here. So switching over to the NAM, looking at the 500 level, this will give us a good idea of that short wave, right? That little blip that's going to come through the system here. So kind of spanning this out here into Monday afternoon, you can see this blip develop here, and this little short wave, this little kink in these lines here, right? And otherwise fairly smooth lines. We're going to see that kink that gets developed here, and that is going to create some disturbance, and that disturbance is going to drive some vertical motion of air, and that is going to, as we mentioned before, generate and strengthen this low pressure system and bring with it that frontal system. And as that continues on, here's our jet streak even showing up in the 500 level, 500 millibar level, and showing that will continue through into Minnesota, across Minnesota, and there we can see our trough strengthen and develop, and that will continue out and eventually move east across the United States. After that passes through, that's going to leave us this really nice ridge, right? And this ridge here, right, this where I'm drawing this arrow like through here, that ridge is going to bring with it more of a high pressure system and a warming trend. So we're going to see some of that weather move on to the east. We're going to see trailing behind it a high pressure system. And, generally speaking, with that high pressure system, we are going to have a kind of broad area here, high pressure with this ridge that sits over here, and it will bring milder and warmer temperatures. So milder, drier weather and warmer temperatures into the Minnesota area, at least through the end of the week. Taking a look at the 500 here, let's do a quick look at vorticity. So vorticity is essentially looking at rotation, so relative rotation in the atmosphere. So as this short wave that we can see here, as this progresses down, it will bring with it a broad set of vorticity maxima and horizontal rotation here into Minnesota. And with that is important in jumping down a level here. I always like to look at the 700 level is what does that do for the vertical motion of air? And so what we're really looking for is some of these, reds into these really bright blue colors to signify negative velocity or rising motion. And that rising motion is what we would be looking for to support storms. So as this short wave moves through, looking at the 700 level, we can see here are these pockets of very strong vertical motion that are going to move through. This is 7 p.m. by the end of today. So that at 0Z Tuesday, which is 7 p.m. Monday, our time. By 7 p.m. this afternoon, we're going to have, kind of a look. At least NAM is showing us a section here that is, associated with vertical motion of air. And this is pretty widespread across Minnesota in pockets. And this is going to make it kind of difficult to forecast exactly which counties, exactly which cities will see storms. It would be difficult to do that. It would just be kind of known that most of this area across Minnesota is going to probably see some cloudy weather and potential for rain today. And this will continue on into Tuesday, maybe a little bit of a break in the morning here, a little bit of a clearing here towards 10 a.m. or so. And then we're going to see, as that comes through, the potential of that, up again here in this yellow area. Still some of that vertical motion here and a little bit down here to the southeast that will create the potential for storms again on Tuesday. So just continuing on and looking at this a little bit closer in Minnesota, let's take a look at surface, like maybe the overall pressure as this changed. So here's this low pressure system is developing today, and this is going to continue to strengthen. You see here dropping down already into 1012 millibar. And this is by 4 p.m. today. So by 4 p.m. or so, you could really see now the definition of this this coming in here and the development of these more tightly stacked isobars. So there's 10, 11 as this even gets developed here. So this is going to create that boundary in that frontal area. And the cold front that's going to shoot out from the side of this, that's going to be our forcing mechanism. So from a timing perspective, looking at NAM, looking at this 10 a.m. here into 1 p.m. here into 4 p.m. here, really starting to see, potentially northeastern, northern Minnesota maybe would be right around the timing here for some of those storms to develop. We might be able to see this a little bit here on temperature as we dive in. So again, here looking 10 a.m. into 1, here we could see a pretty big difference, in temperature here, 80s, 87, 85 to 78 or, 77, 70s into the 60s into this area. So this could be the outline here of our cold front. If we look at, this area, this could be a boundary that represents that cold front pushing down. That will continue on. We will then have cooler temps. You can see as this drops into the 60s again overnight, things will warm up just a little bit. Here further to the south, obviously, as that system pushes through again. And look at this. As we get into the evening hours of Tuesday, we can see temperatures, even dropping below 60 across most of Minnesota. So definitely a cool down, overnight Wednesday before things heat back up again. And as we continue on here, you can definitely see this ridge will push a lot of this warmer temperatures. 100 degrees here across the Dakotas will push, and all continue to push east this way as that ridge, pushes that higher pressure and allows for this more surface warmed air to extend over our way. Looking at some of our ingredients here for storms, dew points, we saw 66, 65, low 60s here across Minnesota. We're going to see pockets of that get into the 70s here, by this afternoon. And that will continue on, through Tuesday. Dew points are going to stay well into the 60s before this general push out here by the end of Tuesday and into Wednesday through the rest of the week. So even more, if you look at the rest of the week as we get in there, potentially, some more milder dew points, overnight and into the morning hours. And then things will heat back up and get nice and seasonally. July, wonderful for us. Thursday, Friday. Let's see here. Let's take a peek at some of our cams for this. So we are looking at overall here mixed layer CAPE. So this is a look at our instability for the course of the day. And this is about 4 p.m. this afternoon. We can see a broad section of Minnesota here in the 1200s, 1300s. So more than enough instability, a buoyancy for that air to rise. And as that air would rise, it would condense and create moisture and clouds and such. But what we're not seeing here is those days where we have the 4,000, 5,000 CAPE, where we have this sort of loaded gun, explosive environment. It's not that. Well, we definitely have buoyancy, but it is not extreme by any means. And again, it's not widespread deep. It is has some pockets in here of fairly low areas. And so as these storms move into those areas, they will generally not be able to continue to, have that rising air as well as they might in some of these other areas. But, this over the course of the day, from the heating of the day, I mean, that's kind of the maximum for today is maybe this 1600 in the central area. And so as these storms develop and push down, this is kind of the area that we want to look towards, the evening where these storms could develop. This will retain a little bit overnight and into Tuesday, and we'll see just a little bit more of that strengthening down in the southeast. But for the most part, the northeastern part is going to be fairly stable environment. So as far as Tuesday, I would tend to say that, from a buoyancy perspective, support for storms is really kind of relegated down here, and is really supported more into this southern part of Minnesota. Let's take a look at our bulk shear component, because again, this is going to be a limiting factor. So you can see across here, again, these single to very low double-digit numbers definitely are not going to do it from a growing supercell perspective. We might see some of that, early as these storms develop here, as this front pushes down. Maybe some development of that, or some pockets. You can see that some of the NAM, or the CAM, the HRRR here is picking up some of the convection with the storms. But for the most part here, this is all pretty low shear across Minnesota, and it never really develops anything super strong. And again, mostly related to the convection up here, and now as these winds shift with the ridge that's moving in, most of that convection and that forcing function, that would be lifting these storms, is all going to be southeast at this point and moving on and out of Minnesota. So now when our bulk shear shows up, our lifting mechanism will have already pushed away and out of Minnesota. And this is already getting into late Tuesday now. That's here. So our bulk shear, just our changing winds with direction, doesn't really show up at all until it's too late, late to the party. So let's take a look at here at some reflectivity. So again, this is HRRR showing that low pressure system develop and move in over Minnesota. You can see it develop here, and towards the afternoon, little blips of some of these isolated storms before this broader pressure widens here, and that cold front pushes down, and we get a little bit of this widespread little pockets of storms that develop. And again, as those continue down and move through, we are now into Tuesday, afternoon, and we are going to see that continue on, and most of these storms just stay, pretty much supported only in the southern part of Minnesota. Maybe a little blippy of stuff here later, but for the most part, this is all going to clear up for us. Another way we can look at this is reflectivity, but focusing on updraft helicity stronger than 75, which is kind of an indication for severe storms. So you can see these, form here, these smaller little storms, but they never really take off. They stay kind of clustered as these little isolated storms. And that's pretty well agreed upon in some of the other models. Like if we take a look at the NAM, even though NAM is going to have a little broader swath across Minnesota for these storms, nothing really develops as a large supercell type system. Just kind of that cluster of linear storms. And then you can see even NAM showing not much except for this, the border of Iowa, for storms to develop here. We can look at one more here and look at, let's look at WRF here, and WRF is going to show a little bit more optimistic of this wider spread scattering, but less severe potential. So just another look at it. And one thing you can do too is HRF it has a composite, they call it postage stamp, of all of these models. So as you go through the day, you could look at all of these and say, okay, let's look at 4 p.m. or so. There's kind of agreement that most of these storms are starting, kind of this Duluth Grand Forks, line, right? So by 4 p.m. that could be an area, but again, pretty much everything north of I-94. And as this progresses in, you can see that the scattering of these, is a little bit different across the models, but for the most part consistent, that we really don't see until about 7 p.m., 8 p.m., most of these models agreeing that storms would make their way down into the metro area of Minnesota. So it's kind of a good way to look at this. And just continuing on overnight here, here's our HRW, and this, just showing here, even between most of these, the NSL and the ARW, just agreement that this continues a little bit here down into Tuesday, but there just is not much for a broad convection and storms by Tuesday afternoon. We're going to start to see that clearing. So fairly good agreement overall for those. And so the last thing, just coming back here, go back to HRRR here and look at our precip forecast. So if I were to do this across the total here for this forecast period, as you can see here, this will kind of track for us total potential precipitation in the forecast. So, 1 inch here by the end of Monday for this little, kind of pocket area, little bits of, nothing to maybe a tenth or a quarter of an inch through here. It does look like, just north of the metro area, maybe up into the, sandstone area. More of that continuation of the rain overnight as it continues to push down here, where maybe in the metro we're going to see between, a tenth, a quarter of an inch to, 3/4 of an inch or so. And, we just play this out and continue this on through. This takes us pretty much through the end of Tuesday into midnight, Wednesday morning. And you can see total forecast overall, pretty low from total rain. There might be some pockets in here of an inch or so of rain, but for the most area, we're looking at a tenth, to potentially some areas of nothing. So a tenth, quarter of an inch, half an inch type rainfall is really all that we're looking at over this 48-hour period. And actually, I lied. One more thing I wanted to show here before we wrap up is you can see here on the crossover. So when we see winds here that look like this, right, where at the low level, we've got a wind that pushes this way, and at the mid level, we've got a wind that pushes this way, and at the high level, we've got a wind that pushes this way. Overall, we're seeing this curvature of winds as it goes up in the atmosphere, and this clockwise rotation of winds when we go aloft, this curvature. We look at photographs and other things. We look at this kind of curvature clockwise. This is called veering, and this veering wind is associated with warm air advection, rising air. And again, that was that rising air that we talked about due to that upper level divergence that we were looking at in the jet stream. We're seeing this rising air. So if you look red, blue to black, and you see this motion where it curves this way, right? The arrows, as they point this way, right? And so what's interesting is if you watch this, and you can still see that motion for the most part, right? Overall, there we still have that same motion. If I skip ahead here into the afternoon of Tuesday, you're going to notice something here. We're going to now get the exact opposite. Now we're going to get the motion that looks like this, right? And this counterclockwise is called backing winds. This is generally associated with cold air advection coming in, and that cold air is sinking air from aloft, right? So this colder sinking air, that sinking air is associated with high pressure. High pressure, sinking, makes sense. And when that air is pushing down, air's not rising. And when it's not rising, it's clearing the sky from clouds. It's allowing for more surface heating. And this is a sign that this low pressure system is moving on out, and then there's going to be an associated high pressure system that's sitting behind this. And so just another indication, if you were looking at this, you can see these winds shift from veering down here to backing up here. It's right along this boundary, that's here. And this is separating the kind of old regime of storms from the new regime that's going to carry us through the end of the week. And this would continue to play out more. And again, this is part of our clearing. And you can see, sure enough, our cape is going to disappear. Our instability is going to disappear. And we're going to have a general backing wind in this area, and you can see a lot of backing wind, through here, which just means high pressure, nicer weather to follow at the end of the week. Okay, so just wrapping up here really quickly, overall from WPC, the excessive rainfall outlook is pretty much non-existent across Minnesota. We saw the precipitation totals there not really creeping at all into the kind of excessive areas, and we have risks just kind of looking across Minnesota. Pretty much, if we just do kind of a refresh on this across the metro area, a little bit of a lightning risk, but excessive rainfall, no. Fog is gone, storms gone. Doing a refresh here, looking up towards the northern part out of Duluth, a little bit of that potential for very light, to moderate excessive rainfall here. And most of that's going to be in this northeastern corner, which is the area we're going to see get rainfall first and kind of keep rainfall the longest. And a swim hazard here for Duluth due to some of those winds and waves off of the lake. Doing a refresh here, looking at the Rochester, so out of the La Crosse weather station. Again, not much for hazards of the area, potential for lightning, potentially with these storms coming through. And looking at the northwestern part, very, very similar type forecast here, as well as looking at the southwestern part, down into Worthington and Sioux Falls area. Again, for the most part, we're looking at really low hazards across these storms. So very rapid, quick look at this. I was trying to get this done in 45 minutes or so. Hope this helps, explain things and understand a little bit of the weather that's going on. And if you have any questions, shoot them my way. But otherwise, hope you can stay dry and hope you have a wonderful rest of the week.